This is basically what we're going to go over. Okay, we're going to be talking about bones and joints. Well, actually, joints and movement. We already talked about bones. So there's two different ways that you classify joints. One of the ways is functional. So how the joint functions, basically how it moves. So you talk about synarthrosis, which basically means that it's not going to move. It's basically stuck together, or an immovable joint. And then amphiarthrosis, which is joints that are semi-movable or slightly movable. Okay? Most of the places where you're going to find these joints that don't move very much is in the axial skeleton. And you remember what's the axial skeleton?
Non-rend bones.
Yeah. The skull, the vertebra, and the rib cage. Okay? And then we're going to have diarthrosis, which is going to be the freely movable joints, and that's pretty much going to be all the extremity joints. There's a few exceptions, but the majority, most of the rest of the joints in the body are going to be diarthrosis, which are the freely movable joints. Then we'll talk about how they're classified in three different structural forms. You can have fibrous joints, cartilaginous joints, and synovial joints. Okay. And we'll talk more about those. But the most common joints in the body are going to be synovial. That's what we're going to spend most of the time talking about. Those are going to be the freely movable joints. And then we'll talk specifically about the different types of synovial joints. And so we'll talk about the shape of the joint, and then also the shape and the function of it is going to determine how it moves. We'll talk about whether it's a non-axial joint, where it's basically just going to slide. It's two surfaces that just slide against each other. Okay? And that's going to be a plane joint. Okay? And then you'll see, we'll show you this later, we're going to be talking about hinge joints, right? They work like a hinge, right? And those are going to be a single axle joint. Then you have condyloid or ellipsoid joints, and they sort of slide against each other like that. You have condyles, so we'll talk more about that. And then a saddle joint is a little bit more complicated version of a condyloid joint. It's basically like, you have a saddle, like a horse saddle. You have two of them fitting together, so it gives a little bit more movement than just a plain condyloid or ellipsoid joint. And then a ball and socket joint. That's going to be like this. You got a ball and you have a socket. Right? So there's a lot of movement that can occur in that. Okay? And then the types of movements that we'll talk about is angular, and that's going to be like flexion, extension, abduction, adduction. Right? And then rotation, which is movement around the central axis and things like this. Right? Talk about rotation of spine, internal rotation in the extremities. And then there's some certain specific movements that we'll talk about that occur at particular joints. Supination, pronation, inversion, eversion, protraction, retraction, elevation, depression, and then opposition. So you don't necessarily need to write all these down because that's what we're going to be doing tonight. So no worries, mateys. All right. Three timbers, the thing will not work. Now, so the joints are going to be the weakest part of the skeleton. Obviously, you're going to have the middle of the bone's going to be pretty strong, but where you have the joints, it's going to be a weak link in the joint, in the skeleton. And an articulation is where two joints are going to meet. Let's see where we are. Well, I don't have page numbers, but it's in the fourth section. So then, the function of the joints are going to give the skeleton mobility. We talked before about the bone, where it gives the skeleton strength. But if you didn't have any joints, it was all just one solid bone that didn't articulate, it wouldn't have any movement. And then also joints are going to hold the different bones of the skeleton together. So then, like I just mentioned, we have functional classifications of joints. So syn means together. So synarthrosis is a joint that's stuck together, it doesn't really move. And then amphiarthrosis is something that's semi-movable. You know, amphi meaning both, like you talk about ambidextrous or amphibious, but has a little bit of movement. And then diarthrosis meaning freely movable joint. So we'll actually spend more time talking about this structural classifications of joints. But again, like I said, most of the joints in the extremities are diarthroses, or synovial joints, or freely movable joints. Like your shoulder, your elbow, your wrist, fingers, all that stuff. Any of these other synarthrosis ones, amphiarthrosis, are mostly going to be in the axial skeleton. There's going to be a few, like down here between the tib and the fib, the joints don't really move, so that's more of a, it's not a freely movable joint. Most of them are going to be synovial. And so then structural is going to be fibrous joints, cartilaginous, and synovial. And then what determines that is what's the materials that join the joint together. And then whether or not the joint cavity. Synovial joints are joints that are going to have a joint cavity, joint fluid, and a lot of other characteristics that we'll talk about later. And so the fibrous joints are bones that are joined by fibrous tissue. And most of those, there's not going to be a joint cavity, and they're not movable. And out of those fibrous joints, there's going to be three different types. There's going to be sutures, which are the bones in the skull. Okay? So suture joints, if you look at them, it's like they're interwoven together. So they pretty much are kind of just locked in together. They look like a suture, like as if you just stitched it all together. And they're pretty much interlocking like pieces on a jigsaw puzzle. And they're not, for the most part, they're not really movable. Okay? There are some, therapeutic techniques and stuff where they talk about, craniosacral types of things, or cranial movements. So we're not going to say that there's no movement in the joints of the skull, but it's not that much. Right? So again, these are joints that are held together by fibers, so they're fibrous joints. And the other one you're going to have is syndesmosis. All right, so syndo meaning that they're bonded together. And then the syndesmosis are going to be attached by a fibrous ligament. And then that's going to be, like I was talking about, in the lower leg between the tibia and the fibula. These bones, there's not that much movement between here, so they're attached by a fibrous band. Okay? Whereas this knee joint here is more of a true synovial joint. So, let's see. Okay, so like I mentioned, the fibrous joints, one of the suture joints are the ones between the joints in the skull. They're interlocking, and then that space in between there is filled with fibers. And they're allowed in the when the infant is growing, you have the spots where the fontanelles, where you can feel on a baby where there's an opening. That's where the sutures haven't come together yet. There's an opening, and as the baby grows and the skull fills in, those fontanelles fill in, and then those fibrous joints allow the skull to grow as the infant's growing. But then later on, they're going to more or less fuse and become a synostosis. And then these are the syndesmosis, which, like I mentioned, is an example is here between the distal tibia and the fibula. So those joints are going to be connected by a fibrous ligament, and they're not going to be really moving that much. And then they're also going to have that between the radius and the ulna.